You probably think fire is something humans discovered by accident. A lightning strike, a volcanic vent, some moment of pure luck that a frightened ancestor stumbled onto and then spent years trying to recreate. That version of the story is comfortable. It keeps humans in the role they prefer, the beneficiaries of chance, clever enough to recognize an opportunity. But the actual history of fire is stranger than that. It suggests something about early humans that most people aren't entirely prepared to accept. The creation of fire wasn't luck. It was an accident. It was a developed technology, refined over hundreds of thousands of years, passed between generations with the same deliberate intention that we now use to pass down written language. Early humans didn't find fire. They built a system for making it, and that system was far more sophisticated than most people realize. To understand where fire making came from, you have to go back further than you probably expect. Evidence of controlled fire appears in the archaeological record at least 400,000 years ago, possibly much earlier. Sites in South Africa suggest fire use dating back nearly 1 million years. What this means is that long before anatomically modern humans existed, our ancestors were already managing flame, not just using fire when they found it, maintaining it, feeding it, understanding at some functional level that fire could be kept alive if you treated it correctly. The question researchers spent decades trying to answer wasn't when humans used fire, it was when they stopped depending on natural sources and started making it themselves. That shift changes everything. It's the difference between an animal that benefits from circumstance and a species that engineers its own conditions. The earliest and most widespread method of making fire from scratch is called percussion fire starting. The concept is straightforward enough. Strike certain types of rock together at the right angle, and the impact generates a spark. Not just any rock, though. Iron, pyrite, and flint together create sparks that burn hot enough to ignite fine tinder. Finding both materials wasn't guaranteed. Ancient people learned which stones worked and which didn't. They carried suitable rocks with them. Archaeological sites across Europe and Asia have recovered nodules of pyrite and flint together, worn smooth from repeated striking, buried alongside piles of what appears to be dried plant material. These aren't accidental arrangements. They're toolkits, assembled by people who understood the process well enough to prepare for it in advance. Here is where the level of knowledge required becomes genuinely remarkable. A spark from percussion doesn't automatically produce fire. The spark lands on tinder. The tinder has to be exactly right. Too dense and the spark dies. Too loose and nothing catches. Too damp and the whole process fails before it begins. Ancient firemakers learned to use specific materials with near scientific precision. Amadou, a spongy material harvested from a bracket fungus called tinder fungus, was one of the most valued fire-starting materials in the ancient world. It catches a spark at extremely low thresholds and holds an ember long enough to be transferred to a larger bundle of dry grass or shredded bark. People weren't just striking rocks together. They were maintaining a working knowledge of local botany, fungal biology, and material science. In conditions where fire meant survival, that knowledge was as valuable as any weapon. Percussion wasn't the only method. Across different regions and different time periods, early humans developed friction-based fire-making entirely independently. The hand drill was used across parts of Africa, the Americas, and the Pacific. A straight, dry spindle of soft wood, rotated rapidly between the palms, pressed down into a notched fireboard, generates enough heat through friction to produce a glowing coal. Sounds simple. It isn't. The wood pairing has to be correct. Softwood on softwood doesn't necessarily work. The specific combination of species matters. The moisture content of both pieces matters. The angle of the notch matters. The spindle has to be straight enough to spin without wobbling. A single miscalculation and you have sore palms and nothing to show for it. People who could reliably produce fire with a hand drill had mastered a skill that took years to develop. The bow drill improved on the hand drill considerably. Wrapping a cord around the spindle and drawing a bow back and forth creates faster, more consistent rotation with less physical effort. This method appeared across Eurasia and the Americas and was still in common use in some parts of the world within living memory. Archaeological evidence of bow drills is harder to identify than flint toolkits, since organic materials rarely survive, but rock art depictions and ethnographic records from the 18th and 19th centuries document bow drill firemaking in extraordinary detail, with techniques that hadn't changed in thousands of years. The bow drill didn't just make fire easier to produce. It made firemaking accessible to people who lacked the raw hand strength the pure drill method demanded. Women, children, and older community members could participate. Fire production became a shared skill rather than a specialized one. What connected all of these methods was something that doesn't show up in the archaeological record directly: knowledge transfer. Making fire reliably isn't intuitive. It has to be taught. A child watching an adult prepare tinder, select stones, strike at the precise angle, and coax a coal into flame was receiving an education. The technique existed in human memory and human hands long before it existed anywhere else. This is part of why the spread of fire-making correlates so closely with population movement. When groups of early humans migrated into new regions, they brought their fire-making knowledge with them. They adapted it to local materials. they refined it. The technology traveled inside human minds across entire continents. There was also a social dimension to fire that often gets overlooked. Producing fire wasn't just a survival skill, it was a form of social capital. Communities that could reliably make fire in difficult conditions had a significant advantage over those that couldn't. In colder climates, the ability to restart a fire from nothing, without waiting for lightning or volcanic activity, was potentially the difference between surviving a winter and not. Anthropologists studying contemporary hunter-gatherer societies have documented how fire-making knowledge is guarded, shared, selectively, and treated as a mark of competence and status. There's no particular reason to think this was different among earlier humans. The person who could make fire was not a simple laborer. They were performing something close to what later cultures would call craft, or even art. The fire plow is one of the lesser-known methods, but it appears across a wide geographic range, from Southeast Asia to parts of the Pacific. A hardwood stick is pushed rapidly back and forth along a groove carved into a softer baseboard. Friction builds heat in the groove until fine wood dust at the far end ignites. It requires sustained effort and good material selection, but it works with fewer specialized components than the bow drill and no projectile-style striking. Communities that developed the fire plow weren't copying anyone. They arrived at a functional solution through observation and experimentation, which means early humans were solving the same engineering problem from multiple directions simultaneously, without contact with each other. By the time anatomically modern humans were widespread, fire-making wasn't a rare accomplishment. It was an expected competency. Campsites from the Upper Paleolithic, roughly 50,000 to 10,000 years ago, show evidence of regular, controlled hearths, stones arranged deliberately, ash pits used repeatedly, fire-hardened tools buried alongside other implements. These aren't accidental accumulations. They're domestic spaces organized around fire, the way a modern home is organized around heat and light. The people who lived in them weren't struggling to produce warmth. They were managing it with routine confidence. Flint napping itself had a relationship with fire-making beyond the obvious. Heating flint before napping it changes the stone's internal structure, making it easier to shape into tools with sharper edges. Early toolmakers discovered that controlled heat could improve their raw materials. This meant fire wasn't just producing warmth and cooked food. It was functioning as a processing technology, a manufacturing stage in the production of other tools. The sophistication embedded in that practice is easy to underestimate. Knowing that a specific type of stone, buried under coals at a specific temperature for a specific duration, would emerge workable in ways it hadn't been before, required a level of systematic observation that looks less like instinct and more like something else. The methods ancient humans developed to make fire weren't primitive attempts at something we later perfected. They were complete solutions to a complex problem, built from deep material knowledge, careful observation, and skills refined across generations of teaching and practice. A bow drill operator from 20,000 years ago wasn't guessing. They knew exactly what they were doing, and so did the person who taught them, and the person who taught that person before. The fire that burned at the center of a camp on a cold night 15,000 years ago didn't arrive there by accident. Somewhere nearby, someone had the tools to make it, the knowledge to use them, and the hands that had done it enough times that it had stopped feeling difficult at all.